Okay, so before we start our module 3.3, we're going to review a little bit of what we did in class today of complex number worksheet. So what you need to remember is that since previously to this point we haven't been able to take the square root of a negative number, however, now we use imaginary, what are called imaginary numbers. We use the letter I to designate that. And so the rule is that I squared equals -1. To simplify that, you would take the square root of both sides, which gives you I equals the square root of -1. The easiest way to remember it is that whenever you have a negative within your square root sign, you're simply, so if we have negative square root of -36, that'd be the same thing as the square root of 36 times the square root of -1. Anytime you have that -1, it simplifies down to I. So then you would have plus or minus 6I. Square root of 36 is 6, square root of -1 is I. Go ahead and try these on this sheet real quick. You should be able to run through them fairly fast, and then come back and check your answers. Okay, checking your work. Number 1 would be 3I, and I'm going to assume you know that all of these are plus minus. Number 2 would be 2I. Number 3 would be 5I. Number 4, the negative is on the outside, so it would normally just be I, but because the negative is in front of that radical, it would be -I. Number 5 is 4I. Number 6 is -7I. Again, you have a negative on before the radical. Okay, 20 breaks down into square root of 4, square root of 5, square root of -1. The 4 and the -1 would give us 2I. Square root of 5 can't be reduced, so we have it like that. Number 8, you have square root of 25. Makes life much easier if you use your perfect squares. If you choose not to do that, you can still simplify them, of course. It's just going to take you more steps. Square root of 25 is 5. Square root of -1 is I. Square root of 3 cannot be simplified any farther than that, so you get 5I square roots of 3. Number 9, you get square root of 25, square root of 2, square root of -1. So you would have 5I square roots of 2. Number 18, square root of 9 times the square root of 2 times the square root of -1 would give you 3I times the square root of 2. Number 96, or excuse me, number 11, which is square root of -96. So if you don't know what that is, I do know that I'm going to have a -1 involved in there. I also know that 12 times 8 gives me 96. You can break both of those down. Just square root of 4, square root of 3, and then just square root of 4 and square root of 2. As soon as I have a pair, that's the number that's going on the outside of the radical. So I have 4, my square root of -1 is I. The 2 that do not pair up go back inside the radical, multiply together, so 3 times 2 is 6. The other way I could have done that was square root of 16 times the square root of 6 times the square root of -1. 16 times 6 is 96 also, so I would have 4I square roots of 6. Okay? 150 is 25 times 6 times -1, so I get 5I times the square root of 6. Very quick, complex number review. Shouldn't be any more difficult than that for you. Okay? Okay, so working on module 3.4, graphing polynomials and end behavior. This is section 7.1 in the text. You'll notice that I'm not giving you problems for this section because we are graphing in class on Wednesday and Thursday. That will take care of your practice problems for this section. However, if you would like extra problems to do for some extra credit, please ask me for those and I will get those to you on Wednesday and Thursday. Okay, so let's just get started by going what we know. We always know that we want our polynomials listed from largest degree to smallest degree in descending order. So let's rewrite this one. F of x equals, our largest polynomial is, largest degree is 3, so 7x cubed minus 5x squared plus x. Then we'll be able to answer these questions easier. What kind of polynomial is f of x? That's a complex polynomial. We have more than one factor. Okay. Actually, let's not use the word complex because that might confuse it with our complex number review that we just did. That's going to be a third degree polynomial. Okay. Has a degree of 3. The leading term is positive 7, so that's positive. We don't really worry what the number is, just whether it's positive or negative. The leading coefficient of f of x is 7. Remember, we talked about in class that if we had y equals 3x plus 2, that has a degree of 1, which is odd. And the leading coefficient is positive. So this polynomial would have similar behavior in the fact that it would start low and end high. This polynomial would have the same behavior. We'll call it polynomial is g of x. This is a linear polynomial. Back here, third degree, we called it a cubic polynomial. Okay. The degree of g of x is 1. We are listed from largest exponent to smallest. The leading term is negative, and the leading coefficient is negative 6. Okay. So they have something called a leading term test, which will help you kind of understand what the function is going to do as far as its behavior. If we're dealing with an even number polynomial, x squared, x to the 4th, x to the 50th, anything that's an even number, and that number is larger than 0, meaning it's not negative, it's going to face upward. It's going to begin up and end up, okay? So it begins, if the leading coefficient is positive, it begins up and ends up. If it is less than 0, the leading coefficient is negative, it's going to begin down and end down. Okay? And that's for any even numbered, even degree polynomial. Only for even degree polynomials. Okay? If it is an odd degree polynomial, 1, 3, 7, 53, it begins and ends on the opposite end, exactly like the line we were just talking about here. Begins low, heading towards negative infinity, ends high, going towards infinity. So, if that number, the coefficient is the leading coefficient is positive, it's going to begin low, begin down, and end up. If the leading coefficient is negative, it's going to begin up and end down. It's going to be going downhill overall. Same thing as slope on a line. If our slope of a linear equation is negative, it would start to up and end down, right? It would have a declining slope. It would be going downhill. Odd number polynomials follow the same behavior. Okay? So for the two down below, we're just deciding what the degree is, what the leading coefficient is, and what the behavior is going to be. So this is a third degree polynomial. Okay? So it's a third degree, so it's definitely odd. So it's going to follow something similar to our linear equations. The sign of the leading coefficient is positive. So think of positive slope. So the end behavior will be, it'll be starting down and ending up. And the another way you're going to see that written is as x approaches negative infinity, meaning on a graph, the farther to the left you're getting, that's approaching negative numbers on the x-intercept. Okay, so for this one we have our zeros at 4, 1, and negative 3. Okay, it's going to start down, curve up, and then end up. So it's going to go up, down, up. That's going to be the graph for this equation. Okay, so as x gets smaller, our y value or our f of x function also gets smaller towards negative infinity. So this means as x approaches negative infinity, our f of x also approaches negative infinity. As x approaches infinity, as it gets larger, our y value also gets larger. Remembering that y and f of x are the same thing, our output gets larger. Okay. All right, let's do the same thing for the next one. This is our polynomial. They've actually factored it all. These are all of our factors for that equation. So let's go ahead and graph those. Oh, what did I do on this one? I actually did the opposite, didn't I? Our solution should be the opposite. So we should have had x equals -4, x equals -1, and x equals 3. 2 points extra credit if you were yelling at me as I was graphing that. Our curve will still be the same. Our points are just a little bit off. So let me go back and just regraph that really quick. Curve is going to look the same. It's just going to be shifted over because I did not take the opposite of my factors, which are actually my solutions. So should have -4, -1, and +3. Still starting down, going up, then down again, then up. Nothing else changed. My graph just needed to shift over a little bit. Okay, so our solutions here should be x equals 2, x equals -2, x equals 1, and x equals -1. Our solutions are always the opposite of our factors. So we have 2, 1, -1, -2. Remember that our x to the 4th is going to look like a W if it is a positive coefficient. If the leading coefficient is positive, it's going to look like a W. If leading coefficient is negative, it's going to look upside down like an M. Okay? So this degree is even. It's a 4th degree polynomial. The leading coefficient is positive. So just like with a quadratic equation, we know we're going to start up and end up. The end behavior will be start up and end up. And the way we'll write that in this notation is as our x value approaches -infinity, as it gets smaller, our f of x approaches infinity. It gets higher. So our graph is going to look something like this. Down, then up, and down, then up. It begins up, heads towards infinity, ends up, heading towards infinity. As our x approaches infinity, as our x values go farther to the right, our f of x value is still approaching infinity. So you notice, on odd-degree polynomials, the behavior is the opposite, depending on whether we're moving towards negative infinity or positive infinity. For even-numbered polynomials, it's exactly the same. Okay? If it begins up, it ends up. Good. Okay. So, here's one that has not been factored yet, so let's go ahead and factor that out. That should be 2x squared. Okay? So what can I factor out of all of those? That would be a -x. I'm going to go ahead and factor out a -x minus 2x plus 1. So if I factor that further, I took the x out because I would like to have a positive x squared left in my factor down here. So x cubed divided by x is x squared. Negative x cubed divided by negative x would be x squared. Positive 2x squared divided by negative x would be -2x, and negative x divided by negative x would be 1. That further factors down to -x, x minus 1, and x minus 1. Now we've got something called multiplicity going on, because another way that I could write this, if my zeros are x equals 0, x equals 1, and x equals 1. Okay? This is what you need to know. If the multiplicity of the 0 is odd, then the graph passes through the x-axis at that 0. If the multiplicity is even, meaning this means the factor occurs an even amount of times, even number of times. Then the graph bounces there at the x-axis. So here we have 0, 1, and 1. Now we do know that it is still a third degree polynomial. Our leading coefficient is negative, right? Negative. So if we think of negative slope on just a linear equation, it would begin up, go down, then back up, and then down. So it begins up, ends down. But now on that one in the middle, at 1, it's going to bounce off of that. So it's going to go down, bounce off that one, and turn right back around and go down. It does not pass through that point. It's just going to bounce off of it and go back down. Okay? If you can think about the two factors as maybe one heading into that point and the other one heading out of that point. Some of you are probably wondering why it's got the table of values over here to the left. You can always utilize a table of values in order to graph anything. Any graph that you ever come up with, you can always plug in values for x, calculate your y, and graph those points. I'm trying to get you to use these functions in a way that you don't have to go through all of that manual work in order to graph them, as long as you can see patterns that happen with the polynomials. Okay? All right, so now for this one down here, f of x equals x cubed minus 5x squared plus 2x plus 8. This is not factored yet. So now what do we do if we're going to try and get this solved so that we can graph our points? So we'll do what we did in class today, Monday and Tuesday, which was using rational root theorem. Okay, I'm just transferring that problem down here. So we know that all of our possible roots or all of our factors of our constant divided by all of our factors of our leading coefficient. So all of our PQs would be plus or minus 8, plus or minus 4, plus or minus 2, and plus or minus 1. Using synthetic division, we're just going to start one at a time trying to figure out which one of those would be a rational root. I always like to start kind of somewhere in the middle, so I'm going to start with 4. I have all of my exponents accounted for. They're all in descending order, so my coefficients would be 1, negative 5, 2, and 8. And I'm simply going to do synthetic division until I find a quotient that has a remainder of 0. That will tell me that this is or is not one of my solutions. So 1 times 4 is 4, negative 1, negative 4, negative 2, and negative 8. Gotta love when that happens on the first try. Okay, so now writing, so x equals 4 is going to be one of my points on this line. That's one of them. Writing my new equation, if that started with an x cubed, this needs to start with x squared minus x minus 2. I need to figure out if that is factorable or not. It is indeed factorable. 2 I get by multiplying 2 times 1. Negative 2 plus 1 gives me negative 1 in the middle. Negative 2 times 1 is negative 2, so those are my other two factors. The opposite are my solutions. So my solutions are x equals 2 and x equals negative 1. Very clean, easy way to be able to graph without having to go through all the hassle of a table of values. So my solutions are at x equals 4, x equals 2, and x equals negative 1. Okay, just transferred those zeros back up here. So I've got them at 4, 2, and negative 1. Now the only thing you have to decide is whether my, it's an odd numbered degree, so it's a third degree polynomial, so that's odd. That's odd. And my leading coefficient is positive. So go back to a positive first degree polynomial. It starts down and ends up. So this is going to start down, going up, going down, going up. Okay, your graph will look like that. Excellent. Let's do a few more, and a few more that are going to include multiplicity. So this should be x squared minus 9, which factors to x plus 3 and x minus 3. So we have zeros of x equals 3 and x equals negative 3. The degree is even. It's a second degree polynomial. What kind of shape should an x squared give you? That should be a parabola. Sign of our leading coefficient is positive. So it's going to begin and end in the same direction. Because that is positive, it's going to begin up and also end up. So our zeros will be at 3 and negative 3. If we need to find our y-intercept, which is always where x equals 0, 0 squared is 0, so our y-intercept to be at negative 9. And there's our parabola there. Okay. They always are going to start and end at the same place when that's an even numbered polynomial. Okay, second one, zeros. Do we have multiplicity? We do have multiplicity. We have the same factor twice. This is what we mean by multiplicity. Okay, and our multiplicity is even. It happens twice. That means that when we hit that point of 3, it's going to bounce off of that point for the graph. So we have a 0 of 3. Now, let's just, for curiosity's sake, let's plug in one larger than that number and one less than that number. So let's plug in 2 and 4. So 2 squared is 4, minus 6 times 2 is 12, plus 9. 4 plus 9 is 13, minus 12 is 1. In theory, 4 should give us the same answer. So plugging in here, 4 squared is 16. 6 times 4 is 24, plus 9. 16 plus 9 is 25, minus 24 is 1. So we also have points at 2, 1 and 4, 1. If you see what happened when we graph this, our graph did bounce off of that 3. It does not go below that 3. Okay? It's a multiplicity of 2. It happens twice. The degree is even. Sign and leading coefficient is positive, so we know it's going to face upwards. And the end behavior will begins up, and it ends up. Okay? It bounces off that 3 because that 3 occurs twice. Okay? Even though that's a simple quadratic equation that you've seen before, you will be using a more difficult polynomials like you have down here on the left. Okay? Okay, so the bottom two equations are already factored for us kindly. So our zeros, do we have any multiplicity going on? That occurs when you have one factor that is occurring twice. So you have it squared to the 4th power to the 5th power, and it's happening twice. So we have zeros at x equals negative 3, and that has a multiplicity of 2. And then we have a 0 at x equals 3. The degree is, we have 3 factors, so it's an odd number, and it's a 3rd degree polynomial, so it's going to be our up, down, up. Leading coefficient is positive, so that means our end behavior is going to begin down and end up. So our points are at 3 and negative 3. This point is where it's going to bounce off of that point and not go through that point. So it's going to begin down, it's going to bounce, not go through, go down, and then back up. Okay. If we wanted to find the actual original equation of that, we would just multiply those back together. So x plus 3 squared times x minus 2 would be x plus 6x plus 9 times x minus 2. And if we multiplied that all out, we would have 6x squared, x cubed plus 4x squared minus 3x minus 18. That would have been our original equation, and we can still verify that's a 3rd degree polynomial, leading coefficient that's positive. And if we plugged in 0 for x to find our y-intercept would actually be at 0, negative 18, which is way down low on the graph. So we're just sketching for now. That's a sufficient sketch of that graph. All right, last one. So the easiest way to count up what degree of your polynomial it is count up all your exponents. When we multiply same base together, we just add the exponents. So 2, 4, 5, 6. So it's a 6th degree polynomial, which means we should have 6 zeros. So we have x equals 0, x equals -2, x equals -1, that has a multiplicity of 2, and x equals 2, that has a multiplicity of 2. So those 2 points are going to bounce. They're not going to go through. So you have 0, -2, -1, and +2. Since it's a 6th degree polynomial, we know it's going to look something like a W, but it's going to have an extra lump in the middle. So it's an even degree. Our leading coefficient is still positive. So it is going to look like a W. So it's going to start up and end up. So the points that are going to bounce are the ones that have multiplicity of 2. So that's going to be at -1 and at +2. And I'm just going to highlight those so I don't forget to get them to bounce there. So they're going to look like down, up, bounce off that one, bounce off that one, like that. Up, down, up, down, up. Sorry, down, up, down, up, down, up. So we've got 6 turns, 6 changes of direction. It's going to bounce right off that one and go straight up. Okay. All right, that's the end for Module 3-4. We're doing lots of graphing practice on Wednesday and Thursday in class. Make sure you bring a pencil, not a pen, to do your graphing in. Graph paper would be helpful. See you then.